Polar's lazy execution is usually explained as faster pandas, but that is not the right mental model. Lazy execution is not a speed button. It means Polars can inspect the full query before running it, and once you can see the query plan, the behavior gets much easier to understand. So in this episode, I'm going to show you the mechanism visually. We'll write a small lazy Polars query, then we'll inspect the plan, because with lazy execution, the plan is the important artifact. I'm Lasha, and this is Pipeline Patterns. Most people hear lazy execution and translate it as one thing. Lazy means faster, and sometimes lazy execution does make a query faster. But that is not the mechanism. The mechanism is 3 steps. Building a plan, optimize that plan, then execute it. The speed benefit when it shows up comes from the optimized plan, not from the word lazy. That distinction is the whole video, so let me make it concrete. If we get stuck on speed, Polars just becomes another benchmark topic. Polars versus Pandas. This tool versus that tool. That is not what I want to focus on here. The better question is, what work does the engine actually plan to do? Benchmarks compare tools. Plans explain mechanisms. For this example, imagine we have a Parquet file called orders. It has columns like customer ID, order status, order total, order date, and then a handful of columns this query does not need. Country, device type, marketing channel, payment method. 9 columns in total. We want to answer one simple question. What is the paid revenue by customer? I want to be clear about what this is. This is not a benchmark. It's a plan inspection demo. The file has more columns than the query needs on purpose. That's what makes projection pushdown easy to see later. Keep an eye on those grayed out columns. We are going to watch them disappear. Here is the lazy Polars query. At first, it looks like a completely normal data frame pipeline. Scan the file, filter to paid orders, group by customer, sum the revenue, then collect the results. But the most important part is scan Parquet. This creates a lazy scan. That means Polars is not immediately reading the file and producing a table. It is building a query plan. The query only actually runs when we call collect. And that leads to the single most important idea in this episode. Until we call collect, Q is not the result. Q is the plan. A so-called lazy frame holds the steps. Read, filter, group, aggregate, without having run any of them yet. And because it hasn't run yet, Polars can look at the whole thing before it does anything. That is the part people miss. The query is available for inspection before execution. Now someone might picture the query running like this. First, read the full Parquet file, load all the rows, load all the columns, then filter to paid orders, then group by customer, then sum the revenue, and then return the result. That's a reasonable mental model if you are thinking in step-by-step, eager execution. But it's not the lazy Polars model. In a lazy query, Polars can see the whole pipeline before it runs the pipeline. And that changes what the engine is allowed to optimize. The order you wrote the query in and the plan that actually executes are not always the same thing. That's the key idea. So because the query hasn't executed, Polars can inspect the whole thing and ask questions. Which rows are actually needed? Which columns are actually needed? Can the filter move closer to the scan? Can unused columns disappear before we even read the file? That's the useful part of lazy execution. And the best part is you don't have to take my word for it. We can just look at the plan. So let's inspect it. First, the non-optimized plan with explain optimized equals false. This shows the query close to the order we wrote it in. Think of it as the before state. Let's look at 2 things here. The filter is a separate step sitting above the scan. And the line where it says project all /9 columns means it read all 9 columns. So in the plan you wrote, Polars reads everything, then filters afterwards. Now let's see what the optimizer does to it. This is the optimized plan. Same query, but with explain optimized equals true. And 2 things have changed. First, look at the scan. The filter is no longer a separate step. It's now a selection living inside scan itself. That's predicate pushdown. Second, project no longer says */9. It says 3/9 columns. Polars figured out it only needs 3 of the 9, and pushed that selection down to the read. That's projection pushdown. 6 columns are never read at all. That's the difference between the query you wrote and the query Polars actually runs. Let me name the two moves because they are worth knowing by name. Predicate pushdown means filter earlier. The filter moves down toward the scan, so the engine can skip rows at read time instead of reading everything and throwing rows away afterward. Projection pushdown means read fewer columns. Unused columns get dropped before reading, and for a columnar format like Parquet, that is real, physical work avoided. But the phrase to keep in mind is when possible. Not every filter can be pushed down. Not every file layout gives the same benefit, and the exact text of these plans change between Polars versions. So don't memorize the formatting. Always inspect the shape. This is also where a lot of explanations go too strong. Lazy execution can improve performance, but it is not a guarantee. It depends on the query shape, the file format, the expressions, the data layout, the optimizer, the Polars version. If the data is already materialized, lazy might not help much. If the query is tiny, you may not notice anything. If the filter can't be pushed down, the plan may not change the way you expect it. And if the bottleneck is somewhere else entirely, lazy execution is not the fix. So the true performance result depends on the case. So here is the habit I actually want you to live with. Before you trust a lazy query, inspect the plan. Don't just check the query runs. Don't just check that output table looks correct. Run both explains, optimized false and optimized true. Then ask a few questions. Did the filter move down? Did the unused columns disappear? Where does the aggregation happen? And this matters even more now that AI writes a lot of data frame code. AI can produce Polars code that runs, but running is not the same as understanding. For lazy Polars, the query plan is part of the review. If you let AI write the code, you should still inspect what the engine plans to do. That's the real skill. Not just writing code that runs, but knowing whether the answer is correct, efficient, and explainable. So let me leave you with the correct mental model. It's simple. Build the plan, optimize the plan, execute the plan, materialize the results. That's it. And one last honest note. A plan can show you whether the execution shape makes sense. It does not prove your business logic is correct. You still have to validate the metric, the grain, and the meaning. But the plan is one of the things you should inspect before you trust the result. That's the whole idea of this channel really. If you want more videos like this on analytical systems, local engines, SQL correctness, and pipeline reliability, subscribe to Pipeline Patterns. Thanks for watching.